So you can look at a tide chart and figure it out and go to the intertidal zone if you want. All right, estuaries. So that's our other type of habitat that you can see where rivers go into the ocean, okay, that are on the edges of the oceans. So you have the intertidal zone, and then you have estuaries. There are three things that are required things are required to have in order to be considered an estuary. The first thing is that they must be semi-enclosed. So they have to have limited access to salt water. Okay? Basically, it has to be enclosed like on three sides by land. All right, so has to have restricted access to the salt water. So semi-enclosed, second thing you have to have is you have to have two water types. So you have to have fresh water and you have to have salt water, okay, from the ocean. Fresh water from the river or stream. The third thing that you need is mixing between those two water types. All right, so you get semi-enclosed, two water types, mixing, estuary. Okay, so those are the three things that you need. So here's kind of what it looks like. So you've got the river running in, okay, ocean, okay, it's semi-enclosed, all right. So it's like partially cut off. You can't have like water coming in from over here, okay. And then fresh water, salt water from the ocean, mixing between the two, and so you've got an estuary. Two terms that you'll hear when referring to estuaries, you'll hear the term the head of the estuary. Okay, that refers to the area where the river's running in. And then the mouth of the estuary is where it opens up to the ocean. Okay? So those are just two terms. All right, so let's look at a couple of places and see if we can figure out if they're estuaries or not. In the map, I'll help you figure out the map. Okay, so this is San Francisco Bay. All right, and everything that's like in yellow and green, that's water, and then kind of like the brownish green color, that's land. Okay, so this is San Francisco Bay, so is it semi-enclosed? Yes. Okay, this red part right here, this is like where kind of a river comes in. So if you've got fresh water and salt water, you've got two types of water, yeah? If you have two types of water, they're probably going to mix, yeah? So San Francisco Bay is actually an estuary. So.
Could it be San Francisco estuary?
Maybe. It's a bay, but it's also an estuary. All right, Monterey Bay. So this is Monterey Bay, just a little bit south, okay, of San Francisco, and this land kind of comes up like here, okay. So is that semi-enclosed? Yeah, it's like three sides, right, that are covered, and this little piece kind of comes up like this. You see that? Okay, so it is semi-enclosed, not as enclosed as San Francisco Bay, but it is semi-enclosed. You do have fresh water that runs in here. You get salt water mixing. Monterey Bay is an estuary. Okay, so parts of it are an estuary. Okay, so we've got four types of estuaries that you can find in four total types of estuaries. Two types that you can find in California. Two types that exist but are not found in California. So the first type of estuary that you will find in California is called a drowned river valley, or a drowned river estuary. Okay, so drowned river valleys are formed when rivers run into the ocean. And when rivers run into the ocean, rivers have a good, strong erosive force on land as they run over land. As they run over the land, they form this valley, okay? Like the Colorado River has formed like the Grand Canyon, okay? So rivers can form valleys. And so as they run into the ocean, they form these valleys. And then as sea levels rise because of melting glaciers and rising temperatures, the sea level rises and fills in that valley that was created by the river, and it drowns the river valley, right? So it's called a drowned river, okay? Estuary. And so now you get salt water, fresh water, because the river keeps running into that same spot. It's semi-enclosed because it's now in that valley, right? Mixing between the two, estuary, okay? So this picture is to show you how Delaware Bay formed. So these like white lines right here, okay, this represents like the valleys that were carved by the rivers as they ran into the ocean. The blue is the sea level, okay, and so sea level rises, fills in those valleys. You see that? Okay, and then you still have the rivers running in, salt water, and you get an estuary. So Delaware Bay is an estuary as well. If the sea levels keep rising, this is what Delaware Bay will eventually look like. All right, at some point. The other type of California estuary is one that you might expect. It's a tectonic estuary. So formed by earthquakes. All right. We had an earthquake like 3 days ago, yeah? Mm-hmm. So tectonic estuary. San Francisco Bay is actually a tectonic estuary. San Francisco is located between two faults. Okay, so you've got the San Andreas Fault right here, and you've got the Hayward Fault right here. Okay, and so tectonic estuaries are formed when you've got like chunks of land in between these two faults, and you get a really big earthquake, and this piece of land between the two faults drops. All right, so you can see this in the picture on the left, right? So different layers. So this piece of land used to be up here because of an earthquake, dropped down. That's a big earthquake, right? So it drops down. Sea fills it in because it's below sea level. Water runs to the lowest point. Okay, so this is a low point now. So rivers and whatever fresh water will start emptying into here. So you get fresh water, salt water, mixing, semi-enclosed. You get an estuary, okay, formed by earthquake. All right, non-California estuaries. So you have two types of non-California estuaries. The first type is a bar-built estuary. You don't find these in California. You do find them on the East Coast, though. And examples would be like Albemarle Sound and Pamlico Sound and Barnegat Bay. And these are formed when rivers run into the ocean. And the rivers are carrying lots of sediment and dirt from coming over land and erosion. And when it gets into the ocean, the water's not moving as fast, and so that sediment has time to settle out, and it will actually form like barrier islands, okay, which will help to cause that to be semi-enclosed. So this is Albemarle Sound, this is Pamlico, and then you see this would be like where your rivers are running in, okay, and then you see this white line right here, yeah, you see that? Can you see kind of like the islands that are right along there? Okay, those are formed from the sediment coming into the river coming into the ocean, and then sediment falling out, and it builds up enough to form like islands, which helps to cut it off from the open ocean and make it semi-enclosed. Do you see that? Yeah? Okay. So it's called the bar-built estuary. Okay, and then the last type of estuary is called a fjord. This is not a fjord, okay? It is a fjord. These you find like in Alaska, but a lot of them will also be like in Norway and Sweden and stuff, okay? And these are formed by glaciers. So glaciers are big chunks of ice that are moving down land towards the ocean, okay? And as they move across the surface of the earth, they have huge erosive powers as well. They can carve deep, deep valleys very quickly into the earth, into the crust. So they carve these big, deep valleys, and then glacier melts. You're left with the valley that's below sea level. Ocean comes, fills it in. Again, low point, so fresh water runs down into that area. Freshwater, saltwater, mixing, semi-enclosed. Yay, estuary. Okay. If you go on like one of the Alaska cruises, a lot of times they'll take you into these fjords. This is what it looks like if you do go in there. Right? You can kind of see the steep sides on there. That's from the glacier carving that big valley. All right. Okay. Water circulation in an estuary. This is very, very general, okay? If you were in honors, you would be learning about like all of the different ways that water can mix in an estuary. So this is just a general overview of what can happen, okay, what does happen. First semester, fresh water, more or less dense than salt water? Less dense, okay? So fresh water, as it comes into the salt water or meets the salt water, the fresh water tends to flow out on top of the salt water because it's less dense. Remember last semester when we made like our little layers of water that we colored and so you could see the separation between the two? Okay, so the fresh water is less dense, so it tends to flow out on top of the salt water. And the salt water, okay, from the ocean comes up the estuary and it gets moved by the tides, right? So the tides will pull it in and out, okay? And so the salt water moves up the estuary. As it moves up, it becomes more and more shallow, okay, which forces that water upwards. And as the water from the river comes out on top and this water gets forced up, it mixes together. Do you see that? Okay, and so you get a gradient from fresh water to saltier and saltier and saltier water until you get to the 35 parts per thousand, which is full on open ocean. Yeah? So that's in general what's going to happen. And so you also get vertical variations in salinity, right? If you start here at the top and you go to like travel in a straight line down, you can get like 3 different salinities. These different colors represent different salinities. You see that? So the salinity will vary horizontally and vertically in an estuary. Whoops. Okay, this is honors. Oops, here we go. Okay, so why does mixing matter? Why do we care? We care because you get the animals that live there care. So do you remember last semester when we talked about osmosis? Yeah. Okay. What happens to an animal if it's placed into a hypotonic solution? Salt doesn't move. What moves? Water. Water goes in. Yes, good. What about a hypertonic solution? Water goes out. Good. Okay, so water is going to move from areas of low water high water concentration to low water concentration, or it's going to go towards the salt. Okay, and so if you're an animal that is living in an estuary, okay, go to here. Okay, let's say you're this little green starfish right here. All right. There is like a variation in salinity. These like variations in salinities will actually move up and down the estuary with the tides. So when it's high tide, okay, you get more salt water entering the estuary, and when it's low tide, more fresh water. You see that? So these like changes in salinities will move up and down. So if you're a little starfish living here, okay, you're going to be subjected to a wide variety of salinities as the tides come in and out. Yeah? Do you see that? Okay. So animals have to be able to deal with these changes in salinity. And you have animals that will do that in a variety of methods. You have some animals that, you know, will change they're called osmoconformers, and they can, you know, change their salinity, and like water concentration changes with the surrounding salinity and water concentration. Osmoregulators will like maintain their salt and water balance no matter what salinity they're in. Okay, so they can either conform or they don't, but you do have animals that are so depending on whether the animal is an osmoregulator or an osmoconformer, they will be considered to be either a euryhaline animal or a sthenohaline animal. So a euryhaline animal is able to withstand a wide variety of salinities. And if that animal can withstand a wide variety of salinities, it is found throughout the estuary, large areas of the estuary, because they can withstand lots of salinities. A sthenohaline organism can only withstand like a very narrow range of salinities, so it can only be found in certain parts of the estuary. So this picture here is to help, again, for you to see how the salinity will change with the tides. So the yellow line would be like where an animal would live, okay, and then this is like 10 parts per thousand, okay, okay, and this would be the salinity that they're in at low tide. And then at high tide, okay, they're in like saltier water, like about 15 parts per thousand. Okay, so it varies. So compare a euryhaline and a stenohaline organism. This represents the estuary. So over here would be like the river, over here would be the ocean. Okay, and these like different colored lines represent the different salinities. So you have 0 parts per thousand, 5, 10, 15, 20, 25. See that? Okay, so a euryhaline animal that can withstand 5 to 25 parts per thousand, okay, a wide range of salinities. We're going to represent it with a green line. Okay, it can be found anywhere from here to here in the estuary. You see that? Because it can withstand any of these salinities. Yes? A stenohaline organism, like this little crab over here, that can withstand 5 to 10 parts per thousand. Red line, okay, it can only be found like right here, because that's where the salinity is that it requires. You see that? Okay, so you have euryhaline and stenohaline organisms. Make sense? Okay, so that's in general the circulation of water in an estuary. We're going to look at a couple of habitats that you find around estuaries.